starts the recording mechanism so that this will be recorded. Welcome, everybody. Glad to have you here. As you can see, well, I got to teach you, I want to show you a few things about Google Hangouts, which is the tool we're using. If you move your mouse a little bit, you'll see that a bar appears on the left side of your screen, and another black and red bar comes from the top. On that one on the top, you can see that you can mute yourself, which I did because I was getting a few strange noises from a few of you. All you have to do to unmute is click the microphone that has a line through it, and that'll get you back online. And then there's a camera. If you click on that, you can remove your picture or bring it back. Anyway, when you want to speak up, just click on that mic and you'll be and then way at the top, if you go to the left bar that's appearing, you'll see there's this blue text thing up there. I would urge you to click that and open it because it opens a chat window, a group chat window on the right. That gives you the option to ask me questions using the chat window. I mean, you can just speak up and ask questions. That'll work just fine. But so anyway, just a little lay of the land. Normally, I have it. I don't normally share my screen so you can see me, but as you can see, I can do that too. So normally what I'll do is I'll have it on this sharing screen, and what you're doing is you're looking at my computer screen right now. Okay. Let's see, what else do I want to show you? Anyway, does anybody have any mechanical questions that you'd like to ask me? Questions about using Hangouts? Hopefully you didn't have any trouble when you clicked the link. I was talking to Travis a little bit about problems if you're using a Microsoft email, which the school uses, then you might not be able to click on the link. I don't know. I hope that wasn't a problem. Okay. So let's talk a little bit about what we're going to try to accomplish today. Now, the title for the lesson is Lesson 1.1 was Graphs and Models. One thing I didn't get a chance to show you yesterday is that when you go to our website, which I'm going to do right now, on our website, you will see, if you scroll down just a little bit, you will see, I'll just pass the syllabus here. Oh yeah, so let me show you this first. There's an alternate calculus website link. When you click on that, a whole nother website is there, which I wrote for calculus. And when you click, the two key buttons here are course notes and sample problems up here on the right. You click on course notes and you'll get lessons, which I will occasionally send you to. When you click on them, this is another whole presentation that might benefit you. It's not the same as the one I give in class, and it should complement it. So that's available. You can go to that anytime you want to. And then the other thing I wanted to show you is after the approximate course schedule listed on the website, there's this link here called Core Exercises. That's got all the assignments in it for this semester. So when you click on that, it's a Word document. I'll just show you what it looks like. You'll see that for each lesson, there is and I just didn't have a chance to do this for today, but the problems. So you see right here, the problems from lesson 1.1 that are assigned for you. I mean, at a minimum, you want to do those. Likewise, 1, 2, 1, 3. And it goes all the way down through chapter 5, which is the goal for us to cover this semester. You'll see that I have many versions of that right in the lesson. So for example, today, when we get to assignment, you'll see that I've got that same thing there, except just chapter 1. Okay, so anyway, we'll be seeing more of that. Okay. So even though because all right, so they're asking me to review all of algebra in 5 days. Okay, that would be like taking your last class that you had and condensing it down to 5 days. Well, that's, of course, humanly impossible. But what I am going to do is try to hit some of the high points. Okay, I wanted to, by you going through lesson 1.1, did you find anything where the language was unfamiliar or where you didn't quite get what they were asking? That would be ideal for you to explore and ask questions about. So this lesson, even though it's called Graphs and Models, I mean, the main presentation I'm going to give you today is concerning functions. You know, functions actually comes a little bit later in I don't know, 1.1.3, I think, but doesn't matter. So what I've done is I've picked out 5 key topics for these first 5 lessons, or 6, that really get you ready for calculus. So there's a slight disconnect, and that's because we're trying to review all of algebra and trigonometry. Okay. Yeah, just a reminder again, if you're not in the session live, you can still ask me questions. The best way to do it, yeah, you know, if you're in the video link instead of the top link, you can still ask questions using texting. It's going to be a little bit hard for me to watch. So I've got the chat window, I've got the live people, and I've got at the same time text messaging, and I might be a little bit late, but I'll get to it. Okay. So here's the topic I want to cover today: an introduction to functions. The first thing I want to, I guess I showed you this already, but remember that there is this alternate website. Oh yeah, I wanted to show you this too. So there's a section, there's a review of calculus on my website too, and if you click it, when you see that, you're going to see this type of material. It's a review of all of the things in pre-calculus. I mean, there's a lot of them. So it's like it's all presented in outline format, and this is on my alternate website. Okay. By the way, at the bottom of that alternate website, you'll see a quiz like this. It says check concepts. This is not, I mean, it's graded, but this doesn't get recorded. So you'll see, you know, there's a number 1, true or false. The set of real numbers are the rational numbers intersected with the irrational numbers. And then if you click choose, you can pick one. And then when you're done, it'll tell you how you did. At least it'll tell you how many correct. Anyway, that's totally optional. You don't have to do that. But there's a lot here. So you could use this outline as a guide to getting ready for calc. So anyway, we've got that. So start off here with 2 of the guys that have a lot to do with the concept of a function. On the left is Leibniz, German guy. And on the right is Leonhard Euler, another a Swiss mathematician. But those two guys are the first ones to use the by the way, Leibniz on the left is one of the co-discoverers of the calculus, which is what we're trying to learn. The other one is, anybody know? Besides Leibniz, the other discoverer? Go ahead. Somebody. What? Still didn't quite hear you.
Is it Newton?
Yep, that's right. Isaac Newton. Thank you. Excellent. Okay. So, function notation, I'm pretty confident everybody has seen function notation before. F of x equals x squared is usually how we say this. And, you know, in the position of that purple x we can plug anything in there. We can say, what's f of 3? And of course, that would be 9. What's f of negative 1? 1 in this case. We can even say things like, what's f of x plus 1? Or what's f of x plus h? And that I'm assuming you're pretty familiar with that. We're going to be digging into that today. So I don't normally use this, but here I have some textbook slides that help us get in this. Okay. So first of all, we have what's called a relation. And a relation is like wide open, no restrictions. Any set of ordered pairs is a relation. So no restriction on a relation. Well, but when you go to a function, now we've got a special requirement here. The special requirement is for a given x, there can only be one function of that, one f of x. And so to give an example here, if two of us were to go to a local grocery store and buy a gallon of milk, the same exact bottle of milk, you know, the same kind and everything, okay, you would expect it would be the same price, right? One person right behind the other in line. If you went through and got charged, I don't know, $1.98 for the milk, and I went through and they charged me $5 for the milk, we would scream unfair, wrong, and that's correct, because a function, when you have a given quantity like a gallon of whole milk, you can only have one result for that. So, and that's what a function requires. So you can't have one time it's this and the other time it's that, and no, it's got to be defined singly. Okay, so the so-called x, the things you can plug in, like how many gallons of milk did you buy, that would be what we call the domain of the function, and the price charged, that would be like referred to as the range. Okay, here's sometimes that's pictured this way. You got your domain on the left, and you got your range on the y. Notice every x on the left points to only one value of y, even though those two cross over on the top. So again, only one. Now, you need to be able to determine if something is a function or not. See, you got somebody, got a little bit of background noise going on here. Hang on. Maria, don't take this personally. Just because of the excess noise, I'm muting your mic. Okay. Okay, so are these a function or not? So now you're just looking at ordered pairs. So when you plug in a -2, out comes a 3. When you plug in a 0, out comes a 0, etc. Is that a function? Yes. Why? Because, first of all, we don't have any repeat x's. -2, 0, 2, 4 are the 4 x coordinates, and none of them are the same, so we're good. As opposed to problem B up here, notice we have two points that have a -1 as an x coordinate, and they have different y coordinates, and that's the violation. You can't have different answers if you're going to have a function. So that bottom set of ordered pairs is not a function. Any questions on that? Anybody? So let's take function notation. We've already looked at it. F of x. Sometimes it said f at x. So here we have a function. F of x is x squared minus 3x. Hello, Osiris.
Hello.
How are you doing?
Good.
Have a little trouble connecting?
Yeah.
Yeah, I'm sorry about that, but I'm glad you're here now. I'm going to mute you because of getting some stray things, but you can unmute yourself. What you do is you move your mouse and this black bar drops down on the top, and you can click on the microphone to if you want to say something. Okay? So back to this slide. A function is defined as take whatever I give you, square it, subtract 3 times the number, subtract 1. I mean, that's my way of saying x squared minus 3x minus 1, right? Whatever I give you, square it, then subtract that same thing I gave you times -3, and then subtract 1. So what is f of -2? So -2 replaces x in the f of x. We simply plug in a -2, and you can see we can then do the arithmetic. -2 squared minus 3 times -2 minus 1, and it comes out to 9. So we would say f of -2 is 9. And by the way, they didn't do this on here, but we can I got to get my pen working. Hang on just a second. Got to jostle my battery a little bit. Blow on it like a Nintendo. Okay, so we could say, in effect, when we plugged in a -2, out came a 9. So f of -2 is 9, and that literally forms a good old ordered pair, -2, 9. All right. So here's another one. Now, you're going to notice different kind of f of here. So this time, we have the function 4x minus x squared. What's f of x plus 2? So x is replaced by x plus 2. So what do? We go into the function and we plug in an x plus 2 wherever there was an x. You'll see that right here. And of course, then we know how to do that. It's called distributive property. Over here, you got a little bit of, you got to multiply out x plus 2 times x plus 2, and you get this trinomial. You bring it all together, simplify it, and you come up with 4 minus x squared. And here's the ordered pair right down here on the bottom. When you plug in an x plus 2, out comes a 4 minus x squared. Now, so there's literally an ordered pair with some algebra expressions there. Okay. So once again, the domain of a function is all the real numbers that you can plug in for x that make sense. So for the expression f of x equals 3x plus 5, you have to think through, is there any kind of a number I can plug in for x that I would not be able to calculate? And the answer is no. Everything works. plug in a negative, you can plug in a square root, you can plug in any kind of imaginable number, yeah, and you can multiply by 3 and add 5. So this domain is everything, all real numbers. So when you're asked to find the domain, what you need to do is probe and say, is there anything I cannot plug in for x? Is there anything that would create this to not be able to be calculated? And the answer is, yeah, over the real numbers, there is. We know we can't take square roots of negatives. And so, for example, x equals 1 is not going to work because f of 1 would be the square root of negative 2, which over the real numbers we don't allow. I know in imaginary numbers you can, but we're gonna be dealing with real numbers mostly. So then, in general, what kinds of numbers will work? And the answer is anything bigger than 3 is going to be fine. And even 3 will work. 3 minus 3 is 0, and the square root of 0 is 0. That's legit. So what's the domain here? 3 and above. And you'll see that expressed right here. The domain is x is greater than or equal to 3. Okay. So some more function notation here. Just in my example, you got f of x equals 3x minus 3. What's f of negative 3? Well, 3 times negative 3 is negative 9. Negative 9 subtract 3, negative 12. So what's f of x plus 1? Plug in an x plus 1 for x. 3 times the quantity x plus, anyway, you can see that after playing around with it a little bit, it's going to simplify down to 3x. So that means when you plug in x plus 1, out comes a 3x. And you can even do, like what's f of triangle? Plug in a triangle for x. 3 times triangle minus 3. Can't simplify that. So when you plug in a triangle, out comes 3 triangle minus 3. Okay. What's the domain on this one? X plus 2 over x squared minus 1. Is there anything that will cause illegal algebra over the real numbers? Yeah, we know we can't have 0 in the denominator. What value of x would cause that to be a 0? Actually 2, right? If x was 1, we'd get a 0 on the bottom. And if x was negative 1, we'd get a 0 on the bottom. Anything else is going to be fine. So we notice this domain, basically they wrote it down here on the bottom. X is every number such that x cannot equal positive or negative 1. So that x slash x is all x such that x cannot. So x can be anything it desires except 1 and negative 1. Okay, so now we come to a really important concept for calculus. It's good old slope. Let me explain what's going on here. So we've got 2 values of x up here. We've got this point and we've got this point. 2 points on that slope line. What is the slope of that line? Well, first we have to identify it. If we call this point x, the y-coordinate from a function point of view is, whatever happens when you plug it in to get, so you got x and whatever result you get when you plug in x. And then over here, if this distance from left to right is h, well then this value right here is x plus h. And the y-coordinate is, well, whatever happens when you plug in x plus h. So Now that we know the coordinates of the 2 points, what's slope? You guys all remember slope, right? I mean, that you all have to have down. Change in x over change in y over change in x. So what is the top? What's the difference between the 2 y coordinates? Well, that y coordinate, see it over here, minus this y coordinate, right over there, divided by, what's the difference between x plus h and x? X plus h minus x is h. So this is just one big happy slope formula. That's all it is. We call it, in algebra, a difference quotient. Okay, so we'll do this one. This is where having a slide prepared just doesn't do it. So let's do it on our own here. So we've got a function. Oh, I got to get my pen working again. Sorry about that. Just a second. Okay, let's try it now. So, there we go. So let's say that's our function, okay? And a difference quotient, I'm just going to remind you, is this. Take x plus h, plug it in, and then plug in the regular function f of x, and then divide by h. So this is the difference quotient. Now, for this specific one, what's f of x plus h? What is f of x plus h? You plug in an x plus h for x, and what do you get? What's 2 times x plus h? Okay, so there's f of x plus h. Now, from that, what's f of x? Well, that's just the thing that's up there. And divide by h. So what happens there? Well, on the top you can simplify. 2x minus 2x, goodbye 2x's. 2h is going to be there. And 1 minus 1, gone. Can you see that it simplifies to that? And of course, h's cancel. So the difference quotient for this problem turns out to be 2. If you're wondering why are we messing around with slopes and this thing called difference quotient, that's the very foundation of what first semester calculus is about. So we're getting ready to do some calculus here. Does anything you need some explanation on up here? Let me know, please. Okay, so there's our first difference quotient. Let's go on and do another. Again, I'm going to do this separately instead of just having you look at this thing that's all done. Okay, so we're going to move off to the side here. And what was the function again? X squared minus 7. Okay. Okay, so there's our function. Your mission, should you decide to accept it, is to find its difference. So basically the problem is find the difference quotient. That's the verbiage that you're going to be seeing. Okay, So we would need to do this again. We need to find f of x plus h minus f of x all over h. Okay, so in this case, what is f of x plus h? I need to get rid of a couple of marks I made here. All right, so what's f of x plus h? Well, so plug in an x plus h for x. So you got x plus h squared minus 7. That's f of x plus h. From that, subtract the original function, f of x, over h. Of course, we need to expand this. What's x plus h squared? You know, you got to hammer that out. You wind up with that double middle term. So after you expand it, you get that. Now, can you simplify the top? Well, x squared minus x squared, that's going to be gone. You're still going to have the 2xh. You're still going to have the h squared. And you're going to have the minus 7, right? I'm sorry. You know what? I forgot the minus 7 here. Right? When you square x plus h squared minus 7, you get x squared plus 2x plus h squared minus 7. And then, all right. So what's going to happen when you do minus 7 minus a negative 7? The 7s are going to drop. So let me get rid of that. And then you'll have that minus 7 on the bottom. That h on the bottom. And this we can simplify by factoring an h out of the top. And now we can finally do that. Final answer to our difference quotient is 2x plus h. Does anybody need me to, can we do a square root 1? Okay, where did I get that from? Okay, text message. All right. Can we do a square root 1? Yeah, a square root of 1 is 1. I got a feeling though you had more to the problem. Could maybe speak up. Anybody who wanted to ask that question, can you do a square root 1? Yeah, square root of 1. Actually, there's 2 square roots of 1, right? Plus 1 and a minus 1. Go ahead. So whoever was unmuting, just go ahead. Speak freely. I'd love to have your question.
Okay, I'm sorry. I meant, can we do a problem like we just did that has a square root in it?
Oh, yeah, that's coming. Yep.
Okay.
Thank you. Good question. All right. Well, I'm not immediate. Well, here, let's go directly to one. Got to find it. Here we go. Let's do this one. Okay. So Maria asked, can we do one that has a square root in it? So here we go. F of x equals the square root of x minus 3. Now, notice I listed after that a comma, which is restricting the domain. Why? Because I know if we pick a value of x less than 3, it's going to cause an illegal calculation over the real numbers. So, okay, so we got to pick numbers greater than or equal to 3. So remember, what are we aiming for? Ah, my pen. Excuse me. A little bit of a delay here. So, no. I got to get a new mini battery so I don't have to mess with this anymore. I don't know if that's the problem, but anyway. So what's a difference quotient? A difference quotient is, again, you need to find f of x plus h minus f of x all over h. You guys have to memorize that. That's what a difference quotient is. By the way, that's supposed to be a parenthesis. Okay, what is f of x plus h? Would you agree what I did up above there? Yeah, just plug in an x plus h where there was an x. So let's plug that in. That's the f of x plus h. Now from that, subtract the original function. And now put that over h. Okay. What are we going to do with that? Well, in order to calculate that, we really need... We can't get rid of the h. And eventually, on these difference quotients, you have to be able to cancel the h. So what algebraically can we do? Remember conjugates? I want to multiply top and bottom by the conjugate of the top. What's the conjugate of the square root of x plus h minus 3 minus the square root of x minus 3? The same thing, only with a plus. That's called a conjugate. And of course, if you do it on the top, you simply must do it on the bottom. So in effect, we just multiplied everything by 1. Okay, now what happens? What happens when you multiply conjugates? Like, for example, what's a plus b times a minus b? A minus b is the conjugate of a plus b. What happens when you multiply that? Do you remember this from algebra? You get the difference of two squares because you're going to have a plus ab in the middle and a minus ab, and they annihilate each other. Guess what? The same thing happens here. So when you multiply that, you get the difference of two squares. What's the square of x plus h minus 3? Under the root. What's the square of that square root? That thing. Minus the square of the other thing. And the problem is we still have a mess on the bottom, but give me a second while I write this out. Oh, that's a government flood watch. Have you noticed how many of those we're getting these days? Incredibly humid. Okay. So, hopefully you get where I got to that point. Now, what happens on the top? Well, x minus x, that's gone. H is still up there. And minus 3 minus a negative 3, that's gone. Okay. So now we're down to this. Now, of course, you can cancel those h's. That's the big thing. Remember I said you always got to get those h's to cancel. And the difference quotient is okay. So a little bit, it's really just an algebra exercise. Let's see, you can't see that, can you? Because gotta move this up. There we go. So there's an example of a difference quotient with a root. And you're right, Maria, that's a challenge that's a little bit harder. Okay, let's go back and let's do let's just do an algebraic fraction. Did anybody have a question on this one? Anything about that? I can't remember. How do I get rid of the pictures in the bottom? Hang on a second. Oh yeah, hide participants. There we go. So now you should be able to see the bottom. Anything that needs clearing up on that, let me know. All right, let's go back and do this fractional one now. All right, this will be another good practice session. So here we have a function, x minus 1 over x squared plus 2x plus 1. And the goal, find the difference quotient. So I'm not going to write it down this time, but what's the difference quotient? F of x plus h minus f of x all over h. So the first thing you got to do in all of these problems is you got to find f of x plus h. Well, let's just plug in an x plus h wherever there's an x. So that would look like that. All right. Simplified. So on the bottom, what do we have? X squared plus 2xh plus h squared plus 2x plus 2h plus 1. So, and we can simplify that. No, that's about as good as we can do. Okay. Now, that's f of x plus h. Well, I guess I better remind you guys one more time. So this is what we're trying to do. So that's what we're trying to find. Now, this is just the f of x plus h we have sitting in this position. So from that, I need to subtract the original. And I need to divide all of that by h. So this right here is the f of x plus h. That's what we just did right above there. From that, we have to subtract the original f of x, and we have to divide that by h. Okay. So what do we need to do from here? Well, how are we going to get that f of x plus h minus f of x together? Well, the answer is we need to get a common denominator. So let me do this in red to differentiate here. So in other words, I need to multiply, I need to get those denominators the same. They're certainly not the same. So this one, I need to multiply top and bottom by x squared plus 2x plus 1. And this one, I need to multiply top and bottom by this big long thing. You know, maybe we can look, now that we know what we're doing, let's look back. This is the only one we have. Okay. So let me make some space here. So we need to multiply this by x squared plus 2x. Oh, gotta get my pen. Having a little trouble with my technical. Okay, plus 2. So that's the beginning, because we got, in order to get this H to cancel, we have to at least get that top into one quantity instead of two, instead of a subtraction problem. Okay, as you can see, there's a lot going on here, and this is going to take a while. Okay. So anyway, now what I would do is multiply out this numerator, this denominator, you know, I would get those together, and now I would finally have a common denominator. I can bring them together, and this can be thought of as, this H on the bottom can be thought of as H over 1. I mean, that's another name for H. And then at the very end, you've got this big, long, hairy fraction on the top divided by H over 1, which is the same as multiplying by 1 over H. And you'll be able to cancel the H's and come to a final result. I don't know if we have enough time to finish this with 3 minutes left, so I'll finish that, maybe, I don't know. I'll finish it, and we can finish it tomorrow. Okay, so you can see I'm trying to really concentrate on difference quotients. Now, one, I didn't have a chance. Here's another fraction. Might have been an easier one to start with because it's a simpler fraction. We can do that. We need to know how to do that. Okay, so I need to talk to you guys a little bit about the homework detail. Okay, now this is my, this is my version. This is my homework for lesson 1-1. Okay, now I know you guys didn't know the exact ones to do, but anyway, here's the 39 to 55 odds part. Let's take a look at what was 39. What was the directions there? Okay. So above 39, it says use intercepts and symmetry to sketch the graph. To find any intercepts and test for symmetry, then sketch the graph. Okay, so now if we go back to mine. So here's the first equation, 2 minus 3x. How do you find the intercept? The y-intercept is what? We know it's 0 comma something. So what does that tell you? Find f of 0. I did that, and I came up with 2. So there's your y-intercept. How do you find the x-intercept? That y equal to 0. Solve for x. So I came up with my 2 intercepts. I plotted them. And then in this case, it's a straight line, so symmetry is out of the question. I mean, there's nothing symmetrical about a straight line. So just sketch your line. So I just wanted to show you, this is about the kind of detail I'm looking for on your homework. Okay. Let's just go look later in the assignment. Yeah, so number 55, okay? X squared plus 3y equals 6. 3y squared equals negative x. So I solved for y, and I came up with these 2 answers. Okay? Here we do have symmetry with respect to the x-axis. And pretty rough sketch, but that's good enough. So I just wanted to show you the kind of homework we're looking for. Let's see, we got another, yeah. So that's something like that. And of course, I don't care how you organize it, but you want to be able to find stuff. So keep things together. Okay, so that's just a rough idea of the homework. Just a reminder, on the main website, there's a schedule of what we're going to do approximately. And then we got these core exercises. So let's see, what is lesson 1, 2? take a look. Oh yeah, linear models of rates of change. So in effect, really, we've already done this because this talks about slope. Okay, see this definition of slope of a line? Well, that's so. Like I told you, I'm not exactly because we got to do all of algebra in 6 days. I'm hitting what I would call the highlights. So this stuff already, this is kind of what I spent time on during our class today. So for next time, you want to try to look through lesson 1, 2 about slope, and then you want to do 5, 11s, the list of the problems here. Okay. So I know we didn't quite finish that problem. We ran out of time. I will be coming back and we'll finish that one up. Now, I got to just see, did anybody leave me a message? Nobody used the chat. Okay, you can use the chat if you want. All right, I think that's it. I will stop the broadcast. Now remember, you should see a 8/28/18 video link within about 5 minutes. Thank you. See you tomorrow.
Yeah.